Welcome to another of my videos where I work through and explain A-level physics multi-choice questions. If you want to try to answer this question yourself, pause the video now. If you got the answer of A, pat yourself on the back. Well done. If you'd like to hear my explanation of how I found the answer, please continue watching. So, a particular baryon has a quark structure down, strange and strange, and decays by the weak interaction. What are the possible decay products of this baryon? The quark structure of sigma plus is up, down, strange. Well, to answer this question, we're going to need to use the data sheet. So I'm going to paste into this the relevant section of the data sheet and now start working through the question. So the first thing I need to do is I need to find what properties this unknown quark made up of down, strange and strange quark has. So one of the properties that needs to be conserved is charge. The down has a charge of minus a third, the strange has a down of minus a third, so one down, two strange quarks will give an overall charge of minus 1. We need to find out what baryon number the quark has. I could just assume that it has a baryon number of 1, but we could, to be 100% sure, we could check the baryon number of a down, strange and strange. Baryon number of the down is a third plus a third. The baryon number of a strange is plus a third, so one down, two stranges gives a baryon number of plus 1. Lepton number, well, it's a baryon number, not a lepton, so the lepton number is 0. And the last thing we need to find is its strangeness. Strangeness of down quark is 0. Strangeness of a strange quark is minus 1. So one down and two strange quarks is going to give strangeness of minus 2. Now, in any interaction, the charge has to be conserved, the baryon number has to be conserved, the lepton number has to be conserved, and strangeness does not have to be conserved if the decay is by the weak interaction. It can change by plus or minus 1. So now what we're going to do is going to look at these products and see whether they have the same charge, baryon number, lepton number, and a change of strangeness of plus or minus 1. So I'm going to draw a little grid across here. Where I can look at the charge, the baryon number, the lepton number, and the strangeness. So this first question, this first possible answer here has this sigma 0 and this pi minus. So first of all, we can look at the charge. Well, we're told it's a charge of 0. This pi meson has a charge of minus 1. So overall, we have a charge of minus 1. So charge has been conserved. Now let's look at the baryon number. It's up, down, and strange. Up has a baryon number of plus a third, down has a baryon number of plus a third, and strange plus a third, so overall a baryon number of plus 1. The meson isn't a baryon, it's a meson, so overall the baryon number for those two adds up to plus 1. Neither of them are leptons, so the lepton number is 0. So far charge is the same as the original baryon. Baryon number is the same, and lepton number is being conserved. So now what we're looking for to see if the strangeness has changed at all. So up, down, and strange. Up has a strangeness of 0, down has a strangeness of 0, and strange quark has a strangeness of minus 1. So this is perfect. Charge, baryon number, and lepton number have all been conserved, but strangeness has changed by 1. Which is perfectly good for a weak interaction. So there's the answer. And if I was doing this in an exam, I'd finish here. But if you want me to go through the others, I will go through the others and you can keep listening if you're interested. Neutron has a charge of 0. Pi meson has a charge of -1, so a charge of -1. Neutron is a baryon, +1. So overall, we've got a baryon number of +1. Neither of them are leptons, so lepton number is 0. So it's looking quite good so far. We just need to see what the strangeness is. Well, a neutron is an up and 2 downs. So the strangeness there is 0. The pi meson has a strangeness of 0 as well. So overall, we've got a strangeness of 0. So that means there's been a change of strangeness by 2, which is too much. That's not allowed. Let's have a look here. We've established that the charge of the sigma 0 is 0. Charge of the electron is -1, so overall the charge of -1. Baryon number overall is -1, and that's because we've established that the sigma 0 is a baryon and the electron isn't a baryon, so a baryon number of 0. The problem we're going to get here is the electron is a lepton, so overall we're going to get a lepton number of +1. So we can immediately see that lepton number has changed from 0 to +1, and that is not allowed. Here we've got 2 K mesons. Well, neither of them are baryons because they're mesons, so the baryon number is 0, not allowed. It's also not allowed because you can see we've got a charge of plus and a charge of 0, so overall a charge of +1, not allowed for that reason either. Neither of them are leptons, so that would be okay, and I'm not even going to bother looking what the strangeness is. So the answer is A. If you found this useful, please press the like button. All comments will be welcome. I hope you'll share and watch more of these videos in the series.